Now we are going to see how the concentration affect the equilibrium. You already know what is equilibrium. Equilibrium means rate of forward reaction is equal to the rate of reverse reaction, and the reaction did not stop, but the concentration of all the chemicals remain constant. Remain constant means they do not become zero, they do not become equal, but they do not change. That's what it tells you. They are not equal. Can you see all of them are not equal? One is higher, other one is smaller, other one is still smaller. So now we are going to make changes to the concentration. What do you do to make changes to the concentration? If you add chemicals, then you are increasing the concentration. If you remove chemicals, you are decreasing the concentration. Now we are starting with certain amount of reactants. Reactants are more, products are zero. So they attain equilibrium at T1 and it remains in equilibrium up to T2. In T2 you disturb the equilibrium. According to Le-Chatelier's principle, you make any change to equilibrium, it will react in the opposite way. If you add some chemicals, it will try to use that chemical. If you remove some chemical, it will try to add that chemical. Now what is the chemical that is added here? Nitrogen. What is nitrogen? A reactant. So if you add some more reactants, the system will try to use the chemical that you have added, so that it can be decreased. Nitrogen is going to be decreased by favoring forward reaction. If you add nitrogen, concentration of nitrogen will increase. The system will try to decrease the concentration of nitrogen by favoring forward reaction. So what is going to happen? Favoring forward reaction means what will happen? Nitrogen will decrease, hydrogen will decrease, but ammonia will increase. Let's look at the hydrogen. Hydrogen is this one, the continuous line, decreasing. What about the nitrogen, which is a dashed line, decreasing? What happened to the dotted line, which is ammonia, which is increasing? Okay, let me also show it here. So what chemical is this? Hydrogen. What chemical is this one? Nitrogen. What chemical is this one? Ammonia. Okay, so we are showing that this one side. So the chemical is added means you will see a vertical line. If you see a vertical line in concentration time graph, a chemical is added. That is a thing. That is a fact that you must know. Now let's go to the rate time graph. How is it going to differ here? Nitrogen is added. You know very well this one is forward. What about this one? Reverse. Because when you start reverse reaction, rate is 0. And both attain equilibrium here. T1 to T2, it remains in equilibrium. That means the rates are equal. Here it is equal. Here they are not equal. Concentrations are not equal, but the rates are equal. So at T2, you are adding a chemical. Nitrogen gas is added. So what happens? Both of them, they go up, but which one goes up? Forward is greater because it favors forward reaction. You add nitrogen, it favors forward reaction. So the forward reaction rate goes up, but the reverse is not going up. Finally, they all attain equilibrium. I also want to make one more change, which is that ammonia gas is removed. If ammonia gas is removed, whenever you add a chemical, both the rates try to go up. Whenever you remove a chemical, both will try to go down. But now what will happen when ammonia gas is removed at time T2? Both ammonia gas is removed. That means this is used up. The system will try to add more ammonia. If you remove, system will add. You have removed ammonia gas, so it is going to produce more ammonia gas. So which reaction is favored? Forward. Can you see forward is above and the reverse is below. So forward reaction is favored. In industrial process of in Haber's process, what they do is to get more ammonia. Because in industry their aim is to get greater yield of the products. The product is ammonia. How can we do that? When it comes to temperature, we must decrease the temperature because this reaction is exothermic. But when they decrease the temperature, the rate becomes very slow. So for practical reasons, they do not decrease the temperature, they increase the temperature. But when it comes to concentration, they add more nitrogen and they add more hydrogen and they remove ammonia as soon as it is formed. So what are the three things? As far as the temperature is concerned, the equilibrium principle says we must decrease the temperature, but when they did it practically, the rate become very slow. So they do not decrease. What they actually do is they increase the temperature and they increase the concentration of nitrogen and hydrogen by adding more and more, and they decrease the concentration of ammonia by removing ammonia as soon as it is formed. Thank you.